Hello everyone. In the series of 8051 assembly language, in the last session we have seen that interfacing of LEDs to the 8051 microcontroller. Now let us see how to interface switch and different output devices. In that part I am taking LEDs. So better we go from hardware to coding part. So in my point of view, so pick up the components from the main library. So required components are microcontroller. So our controller name 8089C51 and second component LED and third component is the switch. So in my point of view, I am connecting switch to the port 1. So as you know that 8051 consists of 4 ports which are known as port 0, port 1, port 2, port 3. All ports are 8-bit ports. This is the connection of switch. So please one by one. So after that connect from port 2.0. So it is the common cathode method. All the cathodes are commonly connected to the ground terminal and anodes are connected to port 2. So now we are programming anode terminals. So what is our case is, when I am switching on, when I click on the switch button, so when we close the switch, then only I need to turn on 8 LEDs. If the switch is open, then turn off 8 LEDs. That's our concept, right? Remember one point, when you are interfacing different components to the IO ports, first of all we should initialize IO ports as input as well as output. Now here, supposed to be enter port 1 is going to be configured as a input, and here port 2 is connected to LEDs. LEDs are the output devices, so that configure port 2 as a output, and port 1 is connected to switch. Then configure respective port 1 pins as a input. In order to do that, write logic 1 for the port 1, because we have to configure port 1 as input. To configure any port as output, you should write 0 before interfacing or before taking the action. We should write 0 for the ports in order to operate as an output. For the input configuration, write logic 1 for the respective ports. This is the hardware configuration. Now let us see the coding part. So I told you that for initialization of IO ports as input and output, initialize port 1 as input. In order to do that, write port 1 comma hash, that indicates immediate data. So in my perception, I am going to configure entire port 1 as a input and configure port 2 as the output, right? So which are the initialization parts. After initialization, so our condition is always read the switch status. Okay, so to read the switch status, we have a single bit instruction as JB and the JMB instructions are there. So now see here, now port 1, when you configure port 1 as input, port 1 all pins will derive logic 1, means 5 volts. Now if you read voltage at this point, you will get 5 volts logic 1. In case if you close the switch, internal 5 volts power goes to ground terminal. So when you switch on the when you close the switch, then you are getting logic 0 at this point. Just we have to understand the status of switch. So it is a digital component. At the port 1.0, you are getting either 0 or 1. It is completely based on the status of a switch. If you open, these 5 volts are remaining at port 1.0. So 5 volts are indicating logic 1 and 0 volts are indicating logic 0. So if the switch is open, these 5 volts are remain same at the port 1.0. That means you are having logic 1. In case if you close it, these 5 volts are goes to ground terminal. Now at port 1.0, the voltage is 0 volts. 0 volts indicates logic 0. That's the logic. Okay. And let's initialize. Switch which was connected to port 1.0 and LED, all LEDs are connected to port 2. That is the initialization. Now read the status of a switch. So when we close the switch, the value is the 0. Jump if no bit on switch, then turn on LED. Jump if no bit, that means if no bit on the port 1.0, then switch on LEDs. That's the case. If no bit means 0. When you are getting 0, if the switch is closed at port 1.0, output voltage is 0. So that is the way of syntax in assembly language. If no bit on the port 1.0, then jump to turn on LED. That's the label. As a label you can mention anything, right? So it will jump to somewhere, turn on. So here simply write. So to turn on 8 LEDs, we should write logic 1 to 8 LEDs of anodes. 8 ones equals to FF in terms of hexadecimal. Always controller is dealing with the hexadecimal. So that here to switch on LED, we have to send 8 ones to the port 2. So now here port 2 represented as LED, or else directly can mention port 2 also. Alright, no issue. Now LED comma hash 0FFH. That's it. So our mode is, if the switch is closed, turn on 8 LEDs. If the switch is open, turn off 8 LEDs. So then short jump to read the switch condition. Okay, in this at here you are reading the switch condition. So if the switch is closed at port 1.0, value becomes 0. At that time it will jump to turn on LED. Here simply you are turning on LEDs. If it is false condition, false means if the switch is open, remaining 5 volts at port 1.0, that means logic 1. So if it is false condition, it don't jump to the target. Target is turn on LED, right? So if it is true, jump to this condition. In case if it is false, it don't transfer to destination. It will execute the execution of next statement. No LED comma turn off 8 LEDs. So keep on read the same status. That's it. So the coding part is over. Let's copy the code. So for every program vector, you create the project, new microversion project. So create a project to file. So in the legacy device, you can find your controller name 8089C51. That's our 8051 microcontroller. So which are the specs of 8051 microcontroller? Click on No for assembly language. So after that, take a new file. So copy your code, and after that, save it. Switch 1.asm. I'm giving the name as switch1.asm. So after that, add your current file to the target or source one. Switch1.asm. Click on add. Close it. You can find. Yes, it was added. So then compile the code. So in the output window, you got one error. Yeah, so we should give same label at the source point as well as destination point. That's the mistake. Yeah, 0 errors, 0 warnings. So after that create the X file. So click on the option for target, enable X file, and give some any other name. So I'm giving the same name, switch and LED. Again compile one more time, translate, build and rebuild. Now your X file is ready. Upload your X file in the microcontroller portion. So you can find it in your path actually. Switch and LED. In the object section, object file, you can find the X file. Okay. So now click on the run button. Switch is open, so that status of LEDs are off. If you close it, now LEDs comes to on. Off, on, off, on. You can see the difference. So this is the condition how to read the switch. Even so, this is the common code when you are connecting any kind of digital inputs. It is the condition. If jump, if no bit, or JB, you can use JB or JNB. So when you take the JB condition, then if one on port 1.0, it take the necessary action. Okay. So understand the point how to read the switch condition, JB or JNB. So here I am taking a reference as a JNB. If no bit on the port 1.0, then take the required action. If you understand the concept, you can apply same concept for any digital inputs. Hope you understand. And supposed to be to control 8 LEDs, I am taking 8 switches. Now how to write the code? Let us see. So in order to do that, first you take 8 switches. Okay. If I close first switch, then switch on first LED. If I close second switch, then switch on second LED. So connect all the switches in this pattern. Now if I close 7th switch, then turn on only 7th LED. If I close the 2nd switch, then turn on only 2nd LED. That's our concept now. So for that, let's write the code. Now we are trying to read entire port 1. Okay. Then read entire port 1, or you can write SW. So if no bit on port 1, wait a minute. Simple scenario is that simply you can take the port 1 status into suppose I am taking into the A register, move A comma port 1. Now you will get complete port 1 status into the A. So if you close the switch, respective port value, port pin value becomes 0. If it is open, port respective pin value becomes 1. So at a time I am trying to read enter port 1 status into the A register. After that, send corresponding status to the port number 2. Move port 2 comma A. That's it. The code is over. I think you are not clear. See, so when you are reading the port 1 status, supposed to be I'm going to close port I'm going to close port 1.0 and port 1.1. The respective those two switches only in the closed state, and remaining values becomes 1. Okay. So first switch port 1.0 and port 1.1, those two are closed. If those two are closed, then port 1.0, port 1.1 will become 00. Remaining switches are open, so that from port 2.2 to port 1.2 to port 1.7 values are 1. Okay. The same value, 8-bit value is taken by A register. So to turn on one LED, the respective LED requires one number. Okay. So before writing actual value, just complement A register. If you complement A register, the value becomes 0. Make the complement. So we are reading the port 1 status. After that, complement A register. After complementing, send the same value to the port 2. That's it. The code is very simple. Yes, no errors. Next file was generated. Now run the simulation. Yeah, we can see the difference. All the switches are open, so that all LEDs are in off state. If you close 8th switch, then 8th LED is on. So whatever the switch is closed, then the respective LED cell comes to on. So here in this pattern you can control individually every LED. So logic is important. If you know the logic, and you can easily apply the program by using assembly language. Thank you.